everyone, let's talk about some synthetic division and the remainder theorem. Okay, so we use synthetic division to divide polynomials by binomials. We can only use it in some specific situations, and we are going to look at those. It is possible to do long division with these polynomials, but that is not for today. Okay? Okay. So, if you remember when we learned division back in elementary school, forever ago, long division, we had to use like a specific symbol. For synthetic division, we also use a specific symbol. We're going to set it up like this. It kind of looks like an L shape. Outside of the L shape, we're going to put a number. We are going to put the opposite of our divisor. So over here, I'm going to write -7. Let me tell you why. So if you recall, in a previous target, we talked about roots, and roots were always written as x minus r. So if x plus 7 was a root, well, it is, we can do x minus -7, and that's how we get x plus 7. So that's why a -7 goes on the outside. All right. Next, what we're going to do is we're going to write the coefficients of this polynomial and the constant. Now, we're doing this to make things a lot easier, and you'll see what I mean. Now, in front of the x cubed, I don't really see any number. However, I know what that number is. It is our invisible 1. I'll write in the invisible 1 here. There it is. Okay. Then I'm going to write an 8, then a 10, then the 21. I'm just going to space it out so I have plenty of room. It's really great doing this on the computer, actually, just because I get so much more space without wasting a bunch of paper. Okay, or making my handwriting super duper tiny. I think the tinier handwriting I try, the worse it gets. Okay, so we have officially set up our problem. So in front of you, you see that -7, which is the opposite of what we're dividing by. And then we have all the coefficients and the constant of our polynomial. The very first step is my favorite. We take the first number and we just drop it down. No matter what that number is. It could have been 752. It would still go down. Okay, next step is multiplication. We take 1 and multiply it by -7. Whatever number was there, that's what I'd multiply. And then I put the answer underneath the 8, -7. Then I add them, going up and down. 8 plus -7 is +1. I'm going to multiply again. 1 times -7, and I plop the answer down here, -7. I'm going to add again. 10 plus -7 is +3. Do you think you know what I'm going to do next? If you said multiply, you are so right. I'm going to multiply, and then, I'm still going to plop it down here. 3 times -7 is -21. And for my final step, I'm adding. 21 plus -21 is 0. That's pretty great. This is the remainder. So if the remainder is 0, there's no remainder. Hooray! This worked out perfectly. We are almost done. We need to write down the answer. This is how we're going to do it. I am going to take the 1 power smaller, and I'm going to write it down here. Now, the reason we take 1 power smaller than the polynomial we're using is because when you take x to the third and divide it by x, we get an x squared. Oops. I'm writing a plus because 1 is positive, and then I just write a 3. There's nothing to put there. That's our answer. I am going to box it. This is a little crazy. There we go. Wow, that is super messy. It looks much cleaner without all the arrows, I promise. And let me make good on that promise and show you. How about that? Let's divide again. I'm going to start my synthetic division by oh, you go right here. Sorry about that. By creating the symbol. Okay. Once again, I'm going to put the opposite of this divisor out here. So we have positive 8 because it's minus 8. And just like before, I'm going to take all of the coefficients as well as the constant, and we're gonna plot them here, giving ourselves quite enough space. Your L shape just is not long enough. You can always make it longer. I'm not usually good at estimating my length, my L shape here, but I'm not. I've just kind of been lucky these past 2 tries. Okay, sweet. We're going to start this problem just like we did the other one. We're going to drop down that first number. Like I said, it doesn't matter what it is. It gets dropped down. Now we're going to multiply. Negative 6 times 8 is negative 48. Then we add 53 plus negative 48 is positive 5. Now we multiply. 5 times 8 is 40. And you know what? You're right. We're going to add 41 plus 40 is negative 41 plus 40 is negative 1. Then I'm going to multiply again. Negative 1 times 8 is negative 8. Oh, sorry, that was messy. And I'm going to add 6 plus negative 8 is negative 2. One more time, guys. Negative 2 times 8 is negative 16. We're almost there. Plus 16 plus negative 16 is 0. Perfect. Okay, no remainder. We're almost done. We just got to put our variables in. We're going to start with 1 power lower. Alright, so I'm beginning with the negative 6, x to the power of 3. It's a positive 5, so I'm writing plus 5x squared. I already have a minus there, then an x, and then minus 2. And we're done with that problem. Fantastic. So just a bunch of multiplying and adding. It looks strange, but it is so quick. It's great. I think this is one of my favorite methods that is actually like a rule in math that you can do that saves you time, because otherwise long division, and it's a little more tedious. Okay, what is the result when x to the third plus 7x squared plus 14x plus 3 is divided by x plus 2? If there's a remainder, we're going to express the result, let me sip some water, in the form of q of x plus r of x over b of x. Q of x is our quotient, that's going to be our answer. R of x is that remainder, the number, and b of x is going to represent what we're dividing by. So, if it's not obvious to you, if we're being told, hey, there might be a remainder, chances are there's going to be. So let's do it. Let's prepare ourselves for a remainder. That's going to be something new. Make this nice and big. Let's get started. I'm going to put the opposite of the divisor. So it's x plus 2. So I'm going to write minus 2. Then I'm going to put the coefficients. There's a 1 in front of the x cubed, a 7 in front of the x squared, 14 in front of the x, and then the 3. Oh, I guess I made my L shape too large. Okay. Just like all the problems we were doing, I'm going to take this first number and I'm going to drop it down. And now let's begin multiplying and adding. Multiply, add, multiply, add, multiply, and add. Okay, so this time we have a -5. That's our remainder. Let's write our answer down. Okay, we need to add in these cubes and x squareds and 14x, like not 14, just the x's. We need to put in all these powers in. However, we don't have a 0 here. So I'm actually going to write the answer right below it because my handwriting does not allow for an easy, nice way of doing this part. Okay, so I'm going to start with one power lower. We had x to the power of 3, so this is going to be 1x squared. Then I have a positive 5. I'm going to then use an x. Then I have a positive 4. And then I have minus 5 over x plus 2. And that's it. So this minus 5 is right here. And I get my x plus 2 right there. Awesome. Let's do another one. Let's draw that L shape. Okay. Let's zoom in. Okay. Now I can make my L shape. Oops. Now I have an x minus 5, so I'm going to write a positive 5. There's a 1 in front of the x cubed, a negative 10 in front of this x squared, then a 20 in front of the x, and then a 26. Let's begin by dropping that 1 down. Let's multiply. 1 times 5 is 5. Add. Multiply. Add. Multiply. And add. Okay, let's write our answer. We started with x to the third, okay? Sorry, dry throat today for some reason. 1 x to the second, we always start with 1 power below, minus 5x minus 5. The 1 was positive, so I write 1 over x minus 5. And once again, I'm just going to do some color coding. The plus 1 comes from here, and the x minus 5 comes from there. All right, we've got a couple more problems. Let's do this. Okay, determine if x minus 3 is a factor of f of x equals x cubed minus x squared minus 41x plus 105. Wow. Okay, so, guess what we can use? Some synthetic division. Let's do it. We're going to write the opposite, so positive 3. Then we have 1 in front of the x cubed, negative 1 for x squared, negative 41, and then positive 105. Okay. Drop that 1. 1 times 3 is 3. Negative 1 plus 3 is 2. 2 times 3 is 6. 6. Negative 41 plus 6 is negative 35. Negative 35 times 3 is negative 105. 105 minus plus negative 105, remainder of 0. Okay, well, what does that tell us? Well, that tells us that if we take the polynomial x cubed minus and divide it by x minus 3, we get a remainder of 0. And you know what? That's the exact definition of what a factor is. A factor is something that divides something else perfectly. No remainders. Now, synthetic division is great, but I'm sorry, but I'm going to show you a faster way now. I know we had to suffer through this first, if you call that suffering, but there's an even faster way to do this. What we're going to do is we're going to take 3 and we're going to plug it in to f of x. So let's do that. We take 3 cubed minus 3 squared minus 41 times 3 plus 105. Okay, I'm going to simplify just a little bit more, and then I'll put it in my calculator. Okay, 3 cubed is 27 minus 9 minus 123 plus 105. Put that in your calculator, you get an answer of 0. Would you look at that? The remainder, when we do synthetic division, it can be found by just plugging that number in. Okay, so there's no remainder, which means yes, it's a factor. So I'll write, let's type, yes, it is a factor because the remainder is 0. Thank you, spell check. Okie dokie. Fantastic. And let's bold that. There we go. All right. We got an answer to this one. So in this next question, when I ask you if x minus 3 is a factor of that polynomial, we don't have to do synthetic division. Let's just plug it in. Okay, so 3 cubed, and I'm getting my 3 from here, minus 2 times 3 squared, still that same 3. Forgot to color code it in the other one, but I'm not going to start this video over. We're too far in. All right, so I plugged the 3 in. Let's simplify a bit more. 3 cubed is 27. Perfect. 3 to the power of 3 is 9. 9 times 2 is 8. Oh, did my 7 not happen? Okay. Is 18. Then I have a 9, and then a minus 6. And that all equals 24. Ooh. Well then, is this a factor of the polynomial? Nope, not this time. Oh no, I want to put it right here. It is not a factor because it has a remainder of 24. Ooh. Okay, sweet. let's see what these are. Okay, what is the remainder when this polynomial is divided by x minus 5? Guys, we were just doing remainders, and we were doing them by plugging things in. So we don't even have to do synthetic division. You just need a calculator that's ready to multiply and add and... Oh, wait. I guess that's the same thing as what we were doing in synthetic division. Multiplying and adding. Oh, goodness. Okay, let's plug this in. I'm going to use this minus 5. Since it's a minus 5, I'm plugging in a positive 5. Okay, let's do it. 5 to the power of 3 plus 9 times 5 to the power of 2 plus 14 times 5 minus 24. Okay, let's simplify just a tiny, tiny bit. Oh no. I'm still drawing. 125. 5 times 5 squared is 25 times 9. Okay, 225 plus 70 minus 24. Let's put that into our calculator, and I get 396. Okie dokie. That is a large number. That is our remainder. All right, one more. What is the remainder when f of x is divided by x minus 5? Once again, all we have to do is plug things in. Let's do it. 2 times 5 to the power of 3 minus 4 times 5 to the power of 2 plus 3 times 5 minus 45. As usual, I am going to simplify just a teensy bit. So 5 to the power of 3 is 125 times 2 is 250. 115 minus 45. We get 191. Okay, well, x minus 5 was not a factor, so I had this giant remainder. I hope this was helpful for you. If you stuck around these whole 23 minutes, you're awesome. Thank you. I hope this was helpful. If not, ask your teachers for some more help. That's their job. We're here for you. We'd love to help you. Have a good rest of whatever day you are watching this on. And I think I made a mistake. I think this is... Did I do this right? Oh well, one way or another, it's not, no, I need to double check. If you're still here, that's good. We're gonna double check. I think it's supposed to be, 191, it's 120. What, it just looked wrong. It just looked wrong. There we go. Okay, well, there's the right answer. We make mistakes sometimes. That's fine. Have a wonderful rest of your day. Bye.